So you may need to do a top machine operation. It's not super common, but if you do need to do one, we can just duplicate our base setup. We can duplicate our base setup just like we did when we created our left setup, and then flip your z-axis, flip your y-axis probably, and then probably adjust your height just to get your top machined appropriately. So you can follow those same steps. Not super common, but if you have to do that to get all the detail in your model, then that's a process that we'll go through. But from here, as I said, Fusion is sort of designed this for a whole bunch of different types of machines and different brands of machines. So what we need to do now is actually generate a code so that the machine can understand it. It's called a post process. So I'm going to hit post process here. This pops up a bit of a warning, of course. Now, the post process that we're going to look for is called Denford. We're using a Denford mill, so you need to choose Denford from the post process list. Well, program number, we'll just leave that 1001. Document units will be millimeters, so you can just leave that as is. It might give you this option to open NC file in editor. That's fine. Otherwise, sometimes it's better just to open it up in Notebook. Now mine will look a little bit different to yours because I'm using a Mac, but we need to make sure that in the properties our built-in high feed rate is 4000. The other ones sort of look like this. That will override any sort of speeds which you've previously put in. So it's best to make sure that that is set up properly. You only have to change it once, but once it's changed, it will stay like that. But it will override any sort of other speeds which you might have got in there already. So we're ready to post process. So I'm going to hit OK. That's going to open this file straight up. Might as well save it. It's important you know where you're going to save this thing because we'll need to copy it onto the USB so we can transfer it onto the machine, which is going to be milling. So I'm going to call this one, it's best if you name it after yourself, so then we know who it belongs to. Just keep it like that. So I'm just going to save this one on my desktop and should open up in a text editor of some sort. Now, as I said, I prefer you use Notebook, so Notepad, to do this. But basically what we have is quite literally thousands of lines of code generated to tell the machine where to send the mill tool, when to change tools, when to start the machine, when to stop the machine, that sort of stuff. So quite literally thousands of lines of code in here. What you will notice is there's the odd one right here and there, which is in brackets, adaptive 1, drill 1. It's important to connect that they are, so drill 1, adaptive 1, parallel 1, drill 1, brackets 2. So we will need to modify that code so that we can add, let me back to the front again, so we can tell the Denford when to turn the stock. So basically, before we do this drill cycle, we'll need to tell the machine to turn the stock around and do the operation on the other side. So we need to add that into the code because it won't know otherwise. So I will do that in my next video. I will show you how to modify that post-processed code for the what we call the fourth axis, so to turn the stock.